Hi, this is Alan with Bothell STEM Coach, and today I wanted to talk about an interesting topic that even my wife debate about and argue about, and I've had a lot of people, students over the years, ask me about, and that is the question of the number 0.999 repeating forever, whether or not that is equal or not equal to 1. Okay, that's the question. So a lot of people have come to me and said, like, I think zero point 0.9 repeating forever is not the same as 1. It is not equal to 1. I can't see how it could be equal to 1. And it does seem a little unintuitive. And there are actually several proofs as to why it definitely is equal to 1. But I want to try to appeal to you through a different arguments, and different ways will appeal to people differently. Okay, so there's one is considered a mathematical type proof that sometimes people like to see. It's that suppose x were an unknown, and that's equal to the number we're interested in, 0.9999 repeating. Well, if I multiplied x by 10, it should move one decimal to the right, and so it should definitely be equal to 9.99999 repeating forever also. And somehow if I subtract these two, it should equal, all the 0.9 repeatings forever should sort of cancel out, right? So I should just be left with, it'd be 9.9999 repeating minus 0.999 repeating. I would just be left with 9. But 10x minus x is 9x, so 9x equals 9, and hence x equals 1. Okay, so this is one kind of quick mathematical proof. Doesn't require a lot of math understanding, and the line of reasoning around why each of these steps is reasonably secure. But I have had students who argue, say like, no, that's not fair. The difference between these two is really 0.00000 repeating with a 1 at the end somehow. So it's not really equal to 9, so you can't make this statement. Okay, that's fine. Another sort of, I wouldn't say proof, but a line of reasoning is this. Well, we know that 0.1 repeating, and we use represent with a line above it, is equal to 1/9. Like if you do 1 divided by 9, you'll find that you'll get 0.1 repeating. And 0.2 repeating is 2 over 9. 0.3 repeating is 3 over 9, or more commonly is 1/3, etc. Hence, 0.9 by this pattern, 0.9 repeating would have to be 9 over 9, and hence 9 over 9 is also 1. So presumably that is a reason why 0.9 repeating is equal to 1. Another one, which I found compelling, like these are all very interesting. Like these are numerical tricks, and they're trying to describe the property of the numbers, and I find them all believable too. But one other thing that sometimes catches people, if is one of the properties of real numbers, of our number system, is that it's dense. And what that means is between any two distinct numbers in our number system, there are an infinite number of numbers between them. So for example, if I consider 1 and 2 as two different numbers, there's 1.1, 1.5, 1.8, and then there's also 1.001, 1.002. Like there's lots of numbers, an infinite number of numbers between 1 and 2. Okay, and it doesn't matter how small, how close together those two numbers are. So, for example, 1.001 and 1.002 also have lots of numbers between them. They have 1.0001, 1.0002, etc. Right? Like there's lots of numbers, an infinite number of numbers still in between them, no matter how close together those numbers are. And one could argue that if there aren't any numbers in between two numbers, then they are the same number, in fact. Right? Does that kind of make sense? Like in our number system, if two numbers are different anyway, then there's an infinite number of numbers between them. So let's consider 0.9 repeating. and the number 1. This is 0.9 goes on forever. What numbers are between there? Is there even one number that would be between 0.9 repeating forever and 1? You can't say I had 0.9 repeating forever because I can't add any number to it and not arrive at 1. There are no number. If you think about it, if you think that these two are distinct numbers, there are no numbers in between the two. So as far as we're concerned, that they must be the same if there aren't any numbers in between them. Because it basically means there's no distance between them. They're basically sitting on the same spot because they're not separated by any distance. Okay? What this all comes down to, these kinds of arguments, has to do with we don't have a language of understanding infinities very well. So to realistically talk about these in any meaningful ways, to come to any consensus, is we have to sort of define what we mean by infinity. Like, we don't have our concept of infinity is somehow it's a big number. Like, some people say, like, when you're a kid, you say the things like, oh, infinity times, and then you say infinity plus 1 or infinity plus 2, right? Like, infinity is infinitely big. You can't add 1 to it, right? And so, but we have this notion that somehow there's infinity and then there must be something bigger than infinity. When we add 1, or infinity times infinity, or infinity times infinity, infinity times, or those kinds of things. We don't have a great, like, intuitive understanding of infinity. We just sort of picture in our head as to be something very big, or just something that goes on very long, but not like forever or infinitely big. You know, so that's where we get stuck in a scenario where we argue about things that are infinite and things don't make sense because we're not applying a set of consistent rules. So part of mathematics is, while tedious, is to define a set of rules that we can agree on, and then that can help explain things. When we talk about 0.9, one construction I'll use for this 0.9 repeating is what we're really saying is it's this. It's 9 over 10 plus 9 over 100 plus 9 over 1,000 plus 9 over 10,000, or 10 to the 4th, plus 9 over 10 to the 5th, etc. Right? In other words, we're saying that whatever the number is, it's a sum of 9 over 10 to the k. K equals 1 to infinity. Now, I've introduced a lot of notation that you may not be familiar with, but this is a simple way of describing the fact that I'm summing these up forever. And the real question is, does this sum equal anything? What would the meaning of such a sum be? And does it in fact equal anything? And I'm not going to go into that today. Perhaps I'll create a video. If there's interest, I can create a video on talking about these kinds of infinite sums. This is a example of a geometric series, in which case there is a sum that we say it converges to. But I just wanted to say that when we look at these kinds of things, it's important to have a commonality, the rules by which we're making arguments. Otherwise, we can have sort of circular arguments about things that go nowhere. So I hope you enjoyed it. I hope it was insightful. Please hit a like or subscribe if you'd like to see more content like this. And yeah,